today's everyday physics lessons, we will be talking about the water bottle flip. Okay, now the water bottle flip deals with 3 different types of physics, or concepts, I guess. Mass, angular momentum, and gravity. Now, it deals with mass because the mass depends on the water bottle and how much it is filled, because as you know, you can't flip a full water bottle or an empty one. And then it deals with gravity because gravity is pulling everything down to the earth, so that deals with it. And then angular momentum, we'll talk about more. Okay. Now, an angular momentum it deals with 2 concepts within that. That is angular velocity which is essentially the speed at which the water bottle is spinning, and then it also deals with moment of inertia, which in this case is essentially how much mass is spread out from the center. Now, if you remember from the angular momentum unit, that momentum is always conserved. From the conservation of momentum law. And then also that angular momentum, angular momentum equals I, which is moment of inertia, times angular velocity, which is the W. Now we can erase that. An example of this would be the ice skater. Because whenever an ice skater has their arms out wide, so rather than close to them, their moment of inertia will be different, because in this example, the moment of inertia will be higher. But since momentum is always conserved, that means the velocity will be slower, so they'll be spinning at a slower rate. Whereas where their arms are tucked together, their moment of inertia is lower, so then their velocity would be higher, so they would be spinning faster. And this is the whole idea behind the water bottle spinning in air with the moving water. And then the skater idea is the reason why the water bottle will speed up and slow down depending on where it is in the flip cycle. Now, another example that you can relate to this would be tossing a coin. Now, a coin does not have moving mass or angular velocity, so therefore its moment of inertia and angular velocity will be constant throughout the whole coin flip, and that is why you don't know necessarily when where the coin will land, like heads or tails, because you can't tell which way it's going to land, because it's just constant. The angular momentum is like constant no matter how you flip it, because the mass cannot move. But in a water bottle, as you move it around, you can see the water moving. Now, the water moving is essentially like the skater putting their arms out or in. As it moves towards or away from the center of gravity, or the center of mass, the inertia will become greater, so then it would be flipping slower. Whereas whenever the water was closer to the center, its velocity will be faster, so in air it will change velocities as it flips because the water will move. And then the reason why the amount of water matters is because whenever you are flipping it, the water will continue to move, and what you want to do is time the water so that it's all coming down like this at the very end, so all the water is pulling it down with gravity and its mass, so it's not still moving around, so there's no angular momentum whenever it should be landing. It should be all just F equals ma, like the mass and acceleration just pulling it down from gravity. But this is why you have to time it or calculate how much water you need, because whenever you flip it, the water will move. What you want to do is whenever it gets into the air, it will start coming down, and then like that. If you have too much water, it will topple over, and if you don't have enough, it will be like flipping a constant mass like a coin, where you don't know where it's going to land because the angular momentum is constant in air. In this part, we will do an actual flip. This one has more water than this one, obviously. Now this one, if you flip it, it doesn't rotate enough to land on it, so it has too much water. See, now what you want to do is find the perfect balance in between the bottles of water. So what we'll do is pour some into the other water. Now this one has less water than the previous one, so if you don't have any water, this would be essentially like flipping a constant mass, so its angular momentum will be constant. So if you flip it, it just keeps rotating and never stops or speeds up.